Hello, welcome to the video. In this video, we're going to be looking at section 4.5, where we're going to look at dilations. So, anytime I think of the word dilation, I always think of when they put those drops in your eyes at the eye doctor, and your pupils get larger. So that dilation means you are changing the size of your figure, and a dilation could be larger. It also could be smaller than the original figure, and it all depends on it's your scale factor. Okay, it all depends on your scale factor. So all of this, it has talks about center of dilation. It talks about all of these other things. But one thing you have to keep in mind is this, is if your scale factor is greater than 1, if your scale factor is greater than 1, it is going to be an enlargement. If your scale factor falls between, I'll just abbreviate, scale factor falls between 0 and 1, it's going to be a reduction. Okay. So once you've established what that is, then we can figure out if your figure was an enlargement or reduction. And another way to look at it is this, is so like here I have a triangle PQR, and I have a P prime, Q prime, and R prime. So the original shape is PQR. All right, P prime, Q prime, and R prime is a dilation from PQR. And since, again, by looking at the figure, it appears larger, my image is larger than the original image, than the original figure. That means it's an enlargement. So that means whatever my scale factor is in this particular instance, I mean, I don't have any data there, it is going to be larger. It's going to be larger than 1. Okay. So if we look at an example like this, they want to know, so like here we have a safety pin, and we have a point of dilation, point C, in both examples A and B. But here, this is point P, and here this is P prime, okay? So P prime is larger than point P, so it is going to be an enlargement. So what that means is to figure out what the scale factor is, you're going to take that larger number, in this case is 12, that gets put in the numerator, and this 8 gets put into the denominator, and then we reduce it from there. So 12 over 8 gets reduced as a fraction of 3 halves, all right? So 3 halves is my scale factor for this particular enlargement. Looking at B, point P is right here, and then P prime is right there. Well, P prime is smaller than the original shape or the original figure. So this is going to be an example of a reduction. And again, since it's a reduction, the smaller number gets placed at the top, and then the larger number gets placed at the bottom. And uh, when we reduce the fraction, it goes to 3/5. So my value for the scale factor is 3/5. So it's 3/5 as small as the original figure. Here it's asking us, it says in a dilation, CP prime is equal to 3 and CP is equal to 12. Find the scale factor. Then tell whether the dilation is a reduction or an enlargement. Okay, so I look at this, oh, that comes from my original figure. This comes from my image. My image is smaller than the original one. I believe that it's going to be a reduction. So since I believe it's a reduction, the scale factor is going to be 3 over 12, which is going to be equal to 1/4. When you are dealing with a dilation in a coordinate plane, you are, whatever you do to the scale factor, whatever the scale factor is, gets gets attached to both the x value and the y value consistently. So here it says whatever values of x and y your original figure is, your scale factor gets multiplied by the same values of x and y. Okay, and it's the same number. So that's why k is being multiplied by both x and y to get your new image. So in this case, this is what p prime is. This is p. So in this particular one, it says graph ABC with vertices A 2, 1, B 4, 1, and C 4, -1, and its image after dilation with scale factor of 2. I'm not as concerned about you graphing it. I'm more concerned about you discovering what the coordinates are. So in this particular instance, if I'm going to write this out, as a rule, it's going to be like x comma y, and since the scale factor is 2, it's going to be 2x comma 2y. So a prime, b prime, and c prime are all going to be multiplied by 2 from the original coordinate. So a is 2, 1, a prime is 4 comma 2. Just multiply it by 2. B is 4, 1, b prime is 8 comma 2, and C is 4, -1. C prime is 8 comma -2. And then you would graph it from there if need be. In this one here, same idea. This one is a scale factor of 1/3, which means it's going to be a reduction. So looking for K prime, L prime, N prime, M prime, and N prime. So with K prime, it's going to be -1 comma 2 when I multiply it by 1/3. L prime will be 0 comma 2. M prime is going to be 1 comma 1, and N prime is going to be -1 comma -1. And that is being able to use dilations. I hope this helps. Until next time.